So this question is called using molarity to find solute moles and solution volume. And again, it's not exactly appropriately named. If you saw a previous video, we're not actually using molarity, we're using millimolarity, which just adds a little bit of complication, but it's roughly the same thing. So calculate the volume in liters of a 1.55 times 10 to the minus 5 millimole per liter, or millimolar, mercury 2 iodide solution that contains 200 microliters of mercury 2 iodide. Round your answer to 3 significant figures. So first, we need a plan of attack. Well, what we're given here is the micromoles of mercury 2 iodide that we have, and what we're looking for is a volume of solution. So we're starting with micromoles of HgI2. Because our solution is millimoles per liter, we need to convert from micromoles to millimoles of HgI2. Once we have millimoles of HgI2, then we can convert to liters of solution. And this is a completely new conversion that you may not have done in the homework before. So here, when we have micromoles to millimoles, there are 1,000 micromoles is equal to 1 millimole. So for each of these conversions, we do need an equality, and here's the equality here. Here is a new equality between millimoles and liters of solution. We have to use the molarity, or in this case, the millimolarity, to do this. If the solution is 1.55 times 10 to the minus 5 millimole per liter, that means that 1.55 times 10 to the minus 5 millimoles of HgI2 equals exactly 1 liter of solution, because it's this many millimoles per 1 liter. So it equals 1 liter solution. So now we have an equality that will allow us to convert from millimoles to liters. You have learned that molar mass will allow you to convert from grams to moles. And that is very important. And you can also use molar mass to convert from moles back to grams. Molarities, and in this case millimolarities, will allow you to convert from solution volumes to moles and from moles to solution volumes if you have the concentration of the solution. These are essentially two ways to find moles, and they come up often in stoichiometry type problems. So let's start here. First of all, micromoles of HgI2 is 200, because that's what the problem says. So we have 200 micromoles of HgI2 times. We want to convert this to millimoles. Well, we want micromoles to cancel out. So we put our 1,000 micromoles on the bottom, 1 millimole on the top, and I'm just going to label these as HgI2 for both of them, times, now we want to convert this to a solution of volume. So we want millimoles of HgI2 to cancel out. So we want to put our, on the bottom, 1.55 times 10 to the minus 5 millimoles of HgI2, and on top, 1 liter solution. To do this, multiply by the top, divide by the bottom, multiply by the top, divide by the bottom. Make sure you're using the 10 to the x or the EE key, depending on if you have a Casio calculator or a Texas Instruments calculator. And when you do all this math, I'm going to write it down here because I'm going to run out of space. If I write it over here, you get 1.2903226 ... times 10 to the 4 liters solution. However, because your original volume, or excuse me, your original number of micromoles was 3 significant figures, you do want to have 3 significant figures. Since this is a 0, you do not round up. So the best answer is 1.29 times 10 to the 4 liters of solution.